Good day, grade 12s. I hope fine. Let me just welcome you to our technical mathematics lesson for today. Today we'll be looking at Euclidean geometry. By the way, my name is Mr. Posa. But before we can go through this topic of today, I just want to advise you that you must have what examination guideline, especially for this topic, because it will outline the important information that you will need during exam and even the reasons that are allowed in the exam time. All right. Now let me take you through this topic. All right. Now under content, as you can see on the screen, we are having our Euclidean geometry. And then this topic itself, it contributes 40 plus or minus 3 marks for paper 2, right? And then when we break this topic, we have the second Euclidean geometry. This topic, remember, we did it in grade 11, right? And then in grade 12, we have dealt with similarity and proportionality theorems, right? Now, when you go to the second Euclidean geometry, the one that we did in grade 11, we have important information that a learner should know. Now, in this case, you say you must be able to state the theorems in words, right? So that it will be easy for you if you are giving a writer to solve, because you'll know all the theorems, right? And 2, you must be able to apply the theorem to solve the writers and give the correct, acceptable reasons. Now, like I've said, that you must have this document of examination guideline. That's where you're going to get what? These reasons, the acceptable reasons. Because every time, remember, when you solve something, you must have a reason. You must reason, right? So it's very important to know all the reasons, right? Now, let me just take you through second Euclidean geometry and see. Now we are having example there. Let us check. Now we are just going to remind ourselves about this theorem, because it's very important, boys and girls, that one should know all the theorems. You must be able to state them, right? Even to know the different type of diagram of these theorems, and then it will help you a lot during your examination. Now, first, let us complete the following theorem. 1, it says the angle subtended by the diameter at the circumference of a circle is. Now, we're going to complete it. Now, the answer for that one is 90 degrees. The angle subtended by the diameter at the circumference of a circle is equals to 90 degrees, right? Now we have another theorem here, which says the exterior angle of a cyclic quadrilateral is equals to what? It's equals to opposite interior angle. The exterior angle of a cyclic quadrilateral is equals to opposite interior angle. Now let's go to number 3. This theorem says a line drawn from the center of a circle to the midpoint of a chord is, the answer for that is perpendicular to the chord, right? It's perpendicular to the chord. The fourth one, it says angles opposite equal sides in an isosceles triangle are equal, right? The last is opposite angles of a cyclic quad are supplementary. So it's very important to go and understand it, even to state these theorems, because they do ask them during the exam. So please go to grade 11, do a thorough revision with regard to these theorems, so that by the time you go to trial examination or the final, you know how to state every theorem, right? Now let's proceed. We are still on cycle Euclidean geometry. Now we are having a scenario now. Let's see what we're having here. It says in the diagram below, meaning they are referring to this diagram here. O is the center. Let's see where is center. This is our center of a circle PMST. RS is a tangent at S. This is a tangent at S. Therefore, angle S1 equals to 56 degrees. We can all see that this is the angle, which is 56 degrees. Then angle O1 is 104. And we are referring to this angle here. All right. Now let's see the type of question we'll get. Determine, state with reason, the following angles. Right. Determine and state reasons, the size of the following angles. The first angle we have to calculate its size is the this angle S2. Where is angle S2? Let us go and identify that angle. This angle is there, this one, this one. Now we are looking for that angle S2. Now, every time when we are answering this question of a circle geometry, from the scenario, you have to pick or understand the theorem that we are having in this question, right? For instance, before answering that question, number one, which is angle S2, you can see that we are having more than one theorem here. Can you see that? First, we have this one of M, T, and S. If you remember this theorem here, let me just indicate so that you can be able to see it. This theorem here with a center here. I hope you recognize this theorem, right? This is the theorem that I've seen. Let me remove this. Now we are looking for another theorem. The other one is this one, having a diameter. Then I believe that you know angle subtended by diameter is how much. So that is another theorem that we're having. So hence I'm saying it's very important to know each theorem. Remember, we're having 9 theorems. So it's very important to know all those theorems, right? And the other one, we're having a tangent and a radius here. A tangent and a radius. So you must be able to know the relationship between a radius and a tangent, right? because we do have a theorem about that, right? Now let's go and answer that question. Let's see how do we go about. Now first, because we are looking for angle S2 there, then we realize that this tangent is perpendicular to radius. Can you see that? And if a line is perpendicular to other line, then where they meet, they form 90 degrees, right? Now from that angle, already we have 56 degrees. So then we're going to say the whole angle, which is 90 there, is 90 minus 56. Then we have to state the reason. Why are you saying 90? Why are you saying that angle is 90 there? Is because the reason is tan perpendicular to radius. Then our answer is what? Is equals to 34 degrees. So we've just determined the angle as 2, right? And then the next question say calculate or determine P angle MS. So which angle are you referring to? Let's go and identify that angle. P, yes, P, angle MS, meaning they are in need of this angle here. The whole angle M, which is angle M1 plus angle M2. So the whole angle we're in need of. Now let's see how do we go about. Now they are saying that angle there is 90. Yes, that's true. What is the reason for that? Angle in a semicircle, right? The diameter. You remember the angle subtended by diameter is equals to 90 degrees, right? So you must be able to state the reason. It's very important, right? Now let's proceed. We then go to number 3, the angle P. Angle P, where is angle P? We are looking for this angle now. We're in need of this angle now. Then how do you go about it? Let's see. Now we say angle P equals to 180 minus into 90 plus 34 degrees. Why? Because remember, we have a triangle is a triangle, PMS is a triangle, and then remember we have already determined what? This angle S2 here. We also have this angle M, angle M, then the third angle, we know how we can determine that. So the reason for that is sum of angles of a triangle, they add up to 180, right? So you're going to add this angle M and together with angle S2, then you minus them from 180. Then you'll get how much? The value of P is going to be, the angle of P is 56 degrees, right? The next question, we had to calculate angle M1. Now let's go and identify that angle there. Let me just remove this and then let us here is angle M1. This is angle M1, right? And remember, we have determined the whole angle M, but this time they just only need this portion here, which is angle M1. Then how do you calculate that? Now, first, what I did, I said angle M2 equals to 104 over 2 equals to 52. Why? Angle at center is equals to 2 times angle at circumference. Now, which diagram am I referring to? This one. This angle here. We know this angle here is twice this angle at angle M2, right? This angle here at center is twice this angle. As we say 104 divided by 2, then we're getting what? Then we got 52 degrees, right? But remember, we haven't answered question. We're still looking for angle M1. Then let's proceed. All right. Now remember, earlier on we have determined angle M, the whole angle M, right? And then we agreed that the angle M equals to 90 degrees, right? Now we've just determined angle M2 here. So what we're going to do to obtain angle M1, we're going to say the whole angle that we've determined, which is 90, minus what? Minus angle M2. Then the angle that we're going to get there is going to be angle M1. Yes, we are having it, which is 38 degrees. So we just determine that angle there, right? So hence I'm saying it's very important to identify what? The theorem that you see in this diagram. Is very important, right? Now let's proceed. Now we are in similarity and proportionality theorem, right? Okay. They are saying a line drawn parallel to one side of a triangle, a line drawn parallel to one side of a triangle divides the other sides proportionally. Which line are they referring to? A line drawn, which is this line DE. This line DE, a line drawn, they are actually referring to this angle, I mean this line there, which is DE. A line drawn parallel to one side of a triangle, right? So previously we had a triangle, which is ABC. Then we had to draw a line, which is DE, that will be parallel to one side of a triangle. Now, in this case, we can all see that DE is parallel to BC, right? Then if that is the case, what's going to happen? It divides the other two sides proportional, meaning this side and this side. So this side is equals to this side in terms of what? Ratios, right? The ratio of this side, this line here, and ratio of this side here, they are equal, all right? And then if that is the case, let's see, then the ratio are, all right. Then let's study this. They are saying AD, where is AD? This is AD, this is AD divided by DB is equals to what? AE divided by AC. Can you see that? Right? The way we have moved on this side, we have to do the same with this side. For instance, we said AD divided by DB, we must also move the same. AE divided by EC, right? Then every time when you write our ratio in that manner, please write the reason for that. And the reason for that is line parallel to one side of a triangle. This is how you should state that reason, right? Line parallel to one side of a triangle. Every time when you write this, you indicate with this angle, I mean with this reason, right? Every time when you say the ratio of this side equals to the ratio of this side. So you state with this reason that say a line parallel to one side of a triangle. And then you can also do this one, right? You can also do this one. For instance, here we said AB, where's AB? This is AB divided by AD, where's AD? AD is here. Can you see that? So the way you went with this side, you're going to do the same on the side. So this is going to be what? AC this time, divide by what? Divide by AE, right? I hope you are following. Let me remove them. So like everything, and the next you can just follow the order so that you can understand. That's how we are going to treat the ratios, right? So it's going to help us to calculate the sides using these ratios, right? Now let's proceed. Now we are having example 1 based on what you've just discussed now. All right. They are saying in the diagram or in the figure below, triangle PQR. Where's PQR? Can you see that triangle? PQR. Here's P, and then this is Q, and this is R. The triangle has TM parallel to QR. TM, can you see that? Here's TM parallel to this side of what? QR, right? And then PQ is here. PQ is equals to 28 millimeter, and PM is to MR is what is equals to 4:3, right? Now, let's see what type of question we might get. All right, determine the length of TR. Determine the length of TR. Where is TR? I mean TQ. TQ rather. This is TQ. Now we are looking for TQ. All right. So we are looking for TQ, right? Now, since we have realized that we've got a triangle, and in that triangle, we have one side, which is parallel to one side of the triangle. We have a line which is parallel to one side of the triangle, right? That line is TM, a line parallel to one side of the triangle. So every time when you come across a triangle that have a line parallel to one side of a triangle, you must know that you are dealing with what? Proportionality, right? Meaning the ratio of this side here is equals to the ratio of this side, right? Now, from our scenario, they have provided us with the ratios. For instance, we have PM here, and PM equals to 4 here. Remember, this 4 is not actual distance. Is what? Is the ratio. It's not actual distance. And then we also have MR, which is 3, right? So at this side, we're having what? We're having 4. We're having 4. Let me just put it 4K to show that 4 is not a distance. And then MR, let's see, this is MR, is what? Is 3. Let me try to put 3 there. It's 3K, right? To show that it's not a distance. We only have one distance on this side, which is 28 millimeters, right? Now, we are going to use what? These ratios together with this distance to determine the length of TQ, right? Now let's do so. Let's do so. Let's see how do you go about it. Now, first, we have to start with what? TQ. So my advice to you is that if they ask you a side, né? For instance, in this problem, they ask us to calculate what the length of TQ. So you always start with what we are in need of. Now, in this case, we're in need of the length of TQ. So you always start with it. For instance, you can see here, TQ, right? Divide by a side where they gave us what the distance, right? Which is, in this case, is PQ. You can see they have provided us with the actual length of PQ, right? So we said TQ divided by PQ, right? Is equals to, now, the way we moved on this side, we're going to do the same on the right hand side, right? Now let me erase. All right, now let me take my pen. So we have started with TQ, then we went to PQ, right? Then we're going to do the same. Now this side we're going to say MR. You can see here's MR. And then next one is supposed to be PR, PR, right? Thereafter, the next step, then we're going to substitute. Remember, we are looking for the length of TQ. So TQ divided by, what is the actual length for PQ is 28, equals to, what is the ratio for MR is 4, and the ratio for PM is, no, actually, ratio for MR is 4, yes, and then for PQ, let me check. Let me check. Oh, it's supposed to be, it was 4 here and then 3. Actually, it was supposed to be what? It was supposed to be, let me just cancel this. It was supposed to be 7 here. This is 7. Now it's going to be 7 divided by 3. Let me try to 7 divided by 3. Because why 7? Remember, from PM we have 4K, and then from MR it was what? 3K, right? But we want the whole ratio from P to R. So the whole ratio is what? It's equals to 7, right? Now it's equals to 7. And then let's see how much you're going to get. So we'll have to fix this question because there was a mistake here. So it was supposed to be 7 over 3. So after this, we're going to cross multiply. Then we're going to say, that's not the correct, sorry. All right. Now we're going to cross multiply and say 28 times 7, which is, this is TQ. TQ is equals to what? If you multiply 28 times 7, it will give you 196 divided by 3. Then the answer that you're going to get there is 196 divided by 3. Right? So this one is not correct because we did a mistake here where we're supposed to write 7. So also this one is not correct. So we are canceling it. So the correct answer for this one is TQ equals to 196 divided by 3, right? Sorry for that mistake because it was supposed to be 7 here. All right. Now we can proceed. Example 2. In the diagram below, we have a triangle MNP. Where's triangle MNP? Can you see that? With R on MP and T on MN is given such that RT, where's RT? Yes, RT is parallel to PN. S is a point on PN such that TS, where's TS? Yes, TS is parallel to MP. It says MP equals to 10 units, RP equals to 4 units, MT equals to 8 units, RT equals to 9 units. Then TN equals to X units, and the last one, SN equals to Y units, right? Now let's see what to calculate. The first question says, calculate and state the reason, the numerical value of X. Which X? This side. We are looking for this side here, right? Now, first we have to identify a triangle. A triangle that has what? A triangle that has a line parallel to one side of a triangle. Now, in this case, we can see this side. This line is parallel to PN. Can you see that? Is parallel to PN there. So this is parallel there, right? Meaning this side is equals to this side in terms of ratio, right? It's a proportionality, right? You remember? Now, how do you calculate that? First, we're going to start with what we are in need of. Remember, it's what I said previously. In this case, we want Tn. We want Tn. Hence, we've started with what? Tn here. Divide what? On that side, we're still on this side. Divide by mt or Tm, right? Because they give us the actual distance there, which is 8 units. So hence we are saying Tm equals to, then remember we went like this and like this. So also here on this side, we're going to say Rp, this is Rp, divided by Mr, right? Then you state the reason, a line parallel to one side of a triangle, right? Now, the next step, we're going to substitute. Since we are in need of X, then we put X there. Tm is equals to 8 there. And then Rp is 4. Then Rm is 10. Then you're just going to cross multiply. Then the value of X on this case is 3,2 units. So we've just determined the value of what? X, right? Now the question still continues. Let's see. Remember, we still have to determine the y here because the y is unknown. Let's do that. Calculate and state the reason, the numerical value of y. And let's see how do you do that. All right, first, we have realized that this side, which is PS, this PS is also equals to 9 units. Why? Because we can see PRTS is what? Is the parallelogram. Remember, the properties of parallelogram. Opposite side are equal, opposite side of parallelogram are equal, they're also parallel, right? So hence this side is also what? 9 units, right? So it's going to help us to calculate the value of y, because here we are having another triangle NMP, because what? TS, can you see TS there? Is parallel to MP, right? Meaning this side of PN is equals to this side of NM, right? In terms of ratio, okay? Now let's proceed. Now we are going to say, because we want Y, so we're going to start with NS there. We have started with NS, that is NS, then divide by PS, this is PS here, right? So equals to, then we are at this side where we are going to say NT, can you see that? Divide by MT or TM, does it matter, right? Then thereafter, we are going to substitute, then y divided by 9 equals to 3,2. Because remember, for NT, we just determined that previously we got the value of x there, which it was 3,2, right? Then after this, we're going to cross multiply because we are solving for y. So we are going to make y the subject of the formula. Now, our answer is now or show, hence, or show with calculation that triangle triangle MRT. Let's go and identify that triangle M. Let me try to show you here MRT. This triangle here, this triangle, this one, right, is similar to triangle TS. This is TS N, all right. And then, all right. Now we are focusing on these two triangles. So we are going to show by means of calculation that these two triangles, they are similar, right? Now let's go and see how do we determine that. Now first, what we did here, since we have this side of NS, which was what, 3,6, right? And we also had this side of NT. We had this side of NT. It was 3,2 from the previous slides, right? And we now having also this side, which is MR is 10. And we're also having this side MT, which is 8, right? And then another one is RT, which is 9 units, right? So what we did here, we have tested with what? With ratios to say RT, where is RT? RT is this one of 9 units. And then over NS, where is NS? This NS here, this one. So when you say 9 divided by 3,6 is going to give you 2,5, right? But remember, we haven't answered the question. Now we go to the other side. Remember, we have used this side of 9 units together with this side of y, right? Then the next side we're going to take is this one of 8 units, which is MT divided by what? Tn, right? So it's 8 divided by what? 3,2. We also get what? 2,5. Then the third one, which is MR, is 10 divided by TS here. TS, we can see TS is going to be 4. So when you divide them, it's going to give you 2,5. Meaning you can see that we have the same ratio there. We have the same ratio there, right? Equal ratio. So if that is the case, then if all the corresponding sides are in the same proportion, then the two triangles are similar, right? Only if these sides, they are in the same proportion. Therefore, the two triangles are similar, right? Then you can also prove by means of what? By means of angles, right? It's a pity that I did not show you with with angles, but I can just talk about it. For instance, let me just remove this. If you want to know that the two triangles are similar, you must also prove in terms of angles. If the angle of the first triangle is equal to the angle of the next triangle, then you must know they are similar. For instance, this angle S here is equal to this angle here. The reason is what? Corresponding angles, because we're having this side is parallel to this side, right? And then this angle here at P is equal to this angle here, because RT is parallel to PN, all right? So if that is the case, therefore this angle S is equal to this angle at R, right? Then we have what? Angle N is equal to this angle here, right? And the third angle, obviously they are equal as well, this one together with this one, right? That means the angle of this triangle MRT is equal to the angle of this triangle TSN. Therefore, the two triangles are what? They are similar. Okay. All right. Thank you very much for being with me. You can now take this activity just to test yourself whether you were with me, and then practice more on this similarity and proportionality, as well as the second Euclidean geometry from grade 11. It's very important. All right. Now, this is your message for today's lesson. That says you may choose to suffer now and enjoy for the rest of your life, or rather enjoy now and suffer for the rest of your life. So please, let us make sure that we do study very hard. Yeah? I thank you.